Okay. Okay. Sorry, I have to do that now because my Alt key isn't working with other keys. I can press Alt and it works, but I can't do like Control Alt Delete. Or maybe I can. Okay, I don't know. One thing that I realized I haven't brought up is all the resources I'm getting. If you just search up UIL computer science, they're right here. So like we're gonna look at the current topic list. This has load. This is like all the new stuff that I was talking about in an old video, and it has literally everything. But this isn't really useful. You can't just like start here at the top and then like search like what does this do? Because like you're skipping a lot of stuff. This part right here is more useful where it's like the topic list. There's a crappy video where this guy right here is actually my professor right now. He's awesome. And then I'll make a video over this and a video over Boolean identities and digital symbols and Polish notation and a class reference sheet, which is a thing at the start of every list. What a great transition, because today our question, using this one, damn, I'm good. Okay, sorry, I won't swear. Is math class methods. So we know how to like add and subtract and stuff, but there's hopefully that there's a lot more in math we can do besides that. So all we have to know for right now, I have seen ones that are not on this list actually, like on last year's test, and they do say like no advanced trig, but I'm pretty sure there was like a really common one that isn't on there. So we'll look at the actual Java, what they're called docs, which like the documentation for the math class, which will tell us all that's in there. But we have these right now, and most of them are self-explanatory, except like these two right here, seal and double. And there's a little thing I have to note about these things on the side that's like int, double, int long. That's just sort of important. So we'll go through that. So the first one is absolute value. And what you'll see here is there's actually two. I'll zoom in. Okay. So we have int and we have double. What this means is you can either send a decimal number or, really, you can send an integer number. This isn't funny. This is only funny when we get to round. Okay, whatever. And absolute value will just get you the positive number equivalent of whatever number you pass in. Passing in, by the way, just means like the like whenever you write a method and then you put data inside. So like, that's unfortunate.
An actual example of the car.
So if we do like absolute value of 4.5, this is going to be equal to 4.
There'd be more.
Something that's important to note is that when we do okay, sorry about that. My roommate came in and he was on the phone, so that's kind of awkward for both of us. When we're modifying a string, like if we have a string variable called a is equal to like blank blank like this, and then you have like some words in between here. If you want to like make a copy that modifies it, you do like a dot to uppercase. We don't do that with math because math uses these things. Well, actually, yeah, math uses these things called static methods. Because fundamentally there's something difference between this string and like ints and doubles and stuff, but that will be way later on. But just know that like when we're using math commands, we do like math dot absolute value. We don't do like, you don't make a variable b that is an int and then do like b dot absolute value or something like that. You will never do this, okay? So it's math dot and then the command, whereas with a string, if there's a variable that is, it's like a dot to uppercase, or you could do like the string a to uppercase or something. This is not a good example because this is the same name as the variable. This could be like ABC to uppercase, right? That's some review from the last one. But basically, if you do like math dot absolute value of 4.5, this will, or of negative 4.5, this will be like replaced, or it will be returned. A value of 4.5 will be returned, and it's the same thing if you put 4.5. So there is something technical we do have to get into, and it's not really that bad. But you see the second word right here is like int double int int. That's kind of nice. This says what kind of number is returned. And what you need to know is that if you pass an integer in, so let's say we pass math.abs of -4, this will return the value 4. Just this, okay? And why is this important? Well, if we do system, I'm not gonna type it out. Hopefully we know it out. Hopefully we know it by now. But like system.out.println, and we do math.absolute value of -4 divided by 7 or 8, this is going to be equal to 0. And the reason for that is back in episode question 2, I think, we went over how, like, if you have an integer divided by an integer, your answer is an integer, so we're going to truncate whatever decimal is here. So even though the real answer is 0.5, we truncate it and we cut it off, so this doesn't exist. But if you pass in a value of math.absolute value of -4.0, this will, when you pass it through here, so instead of being -4, it's -4.0, this will now be 0.5, because this basically says what number will be returned. Okay, so we have math.pow. Actually, I'll demonstrate that real quick, just in case you don't believe me. Oh, is this in my UIL example? Oh no, it's not. I'm sorry, Mike. Okay. Oh, actually no. I thought that was from one of my assignments. It's not. Thank goodness. Wait, where am I? Okay, here it is. So I think we're. Oh, we don't know what this is. Ignore this. Okay. So we're gonna do system.out.println and then math.absolute value of 4 divided by 8. Now we actually have to. I don't know why we don't have to import the math class, but we should. But that doesn't matter. We don't need to know that. So it's 0, but now if we add 4.0, now it's 0.5. So just know that. So we have power. I'm honestly just gonna like go through these and write them out. So it's math.pow. Fudge. I wish I could just like zoom into the text, but we'll do that later. Okay, so math.pow. There are 2 numbers you put inside. So actually, we'll do it for easier stuff. We'll just make a variable a, so it's easier to like understand. So we have int a, and we're gonna say it's equal to, or I guess double a, and I know it's supposed to be double because we see all these right here are all double. Okay, double a is equal to math.pow, and we're gonna do like 2 and then 3. And what this says is a is now going to be 2 raised to the 3rd power. So the first number is called the base. The second number is called the exponent. Okay. So this is really nice because otherwise, if this didn't exist, we'd have to do 2 times 2 times 2 like this, because that's how you would do like 2 to a power. And then like imagine like 2 to the 30. Like that's a lot of 2's you'd have to write out. You'd have to use something called a for loop, which we don't have. So we'll see that this is a big number. But you'll kind of notice right here, like 2 to the 30 should be a very big number. But we'll see that like right here, it's like 1.07. What's up with that? Why is it so small? Well, the actual reason is if you notice on the end here, there's E9. And this is like in your scientific or your science class where they're talking about scientific notation. This is the same thing as saying times 10 to the 9th. So I'll just write that out. Where if we have like 4.0, I guess, for 2 sig figs, times 10 to the 9th, in like the console, how this would be printed out is 4.0 e to the 9th. And technically it'd be like 4.0000000, and then like a random number here, like 9. This is supposed to be 0, sorry. 0, and then it would be e to the 9 or something. But yeah. Something like that. So yeah, these two are the same. Actually, we can do that. Let's do 4 times, and then scientific notation would be 10 raised to the 9th power. So it'd be like this. This is a good example, right? And let's see what it runs. 4 point. Okay, never mind. It didn't do a bunch of. That's float. Sorry, double won't do that. Actually, I don't think double will do that. But if I made this like float, actually, I don't even know if math. Yeah, math doesn't even work with float. Okay. And I'm not going to cast it. Okay. Just ignore that. I haven't even taught float, but you don't need to worry about it. Okay, so there's also a square root, and this just takes a number, and it will return the double. And hopefully you can see that if you have a square root, it's going to return a double value as opposed to an integer, because like a square root will very rarely be an integer, because perfect squares are not that common. So if we take like 37, we can see that it's going to be like I'm going to guess 6.12. Oh, I meant, wait, what? Oh, I multiplied it by 4. 6.08. It's pretty close. Okay. So that's how square root works. The next one's interesting. The next two. So one of them's called ceiling and the other is called double. And how this works is so it would be like math dot and it's ceil of, what did I say? The next one's called double. The next one's called floor. I don't know why I said double. Ceil of 4.9, and then there's also math.floor of 4.9. Okay. And all this will do is go up to the next integer, and floor will go down to the next integer. So floor will be 4, and it's going to return, for some reason, 4.0, which is really confusing, because like if you're just going to go up or down, why wouldn't you just return an integer? And I'm honestly not sure why. I can't think of a legit reason as to why you do that, but that's the thing. So even though it goes against intuition, floor, even though it will return something like an integer, it will, or an integer value like 4, it's going to be returned as like 4.0 or 5.0, which is important when you're actually printing it out, because like literally answer choice A will be like 4, and answer choice B will be 4.0, and you have to know like which one's the right one. So they will do that. But it's more confusing when you do like math dot ceil of negative, like let's do 4.9. Because like now you're in the negative, so is going up -5 because you're increasing the magnitude, or is going down because it's becoming more positive, so it's maybe like larger or something? Well, the way that you can just think of it is think of like a vertical number line. So we have like 3, 2, 1, 0, -1, -2, -3. And I think this actually may be why they call it this. I just made this to help me with it, but like it kind of makes sense. So when you go ceil, so like here's -4.9 for example. When we go ceil, we're going towards the ceiling, towards this next number. So we'll hit the ceiling right here at -4. So then it will return -4.0. Whereas if we have, if we do math floor of -4.9, this will go down to 5. Right, so we'll just do that. Ceil of -4.9, and we print it out. We'll see it's -4, and then if we do floor of -4.9, we get -5. Okay, not bad. Cool. Something I'm curious about. What happens if you put math of floor? Or of let's not do 4. God dang. Let's do math.floor of 5. I would think this should just stay at 5. It is, and even if you pass an integer in here, it's still going to be returned as a double, which is super weird. I actually don't know why. Okay, but just remember that these two will return double, and if you're ever stuck, just make your vertical never sure. Okay, we got min and max. And what this does is it will just return the minimum of two numbers you pass in. So if you pass in -2 and 5, then it will return -2, and then if it's max of -2 and 5, it will return +5. I'll just do that. Min -2, 5, print out, and it's -2. Oh, and it's -2.0, which again is really weird. I don't know why they do that. Okay, whatever. Wait, whoa, wait, what? Oh, it's because it's a double. My bad. Actually, okay. I may have made a mistake actually in the past. I may have been misleading. Because what happens is I think I talked about this. If you have double A is equal to an integer value, that integer is still going to be stored as a double even if it's in an integer because it's inside a double variable. But if we do int a, but this is still double because it's saying you can't store a double, which would be returned here into an integer a. Okay, so my bad. But if you do like math.min, okay, of -2 and 5, this will return an integer, as we can see here, okay, because int a. But if the variable, even though it's returning an integer, if your variable is a double, it will go up to -2. Now, what I'm curious about is what happens if one of them is negative, or one of them's double, and one of them's I'd imagine now it's going to return it double. I don't even know if you can do this. Okay, you can. Okay, you can. So if one of yours is an integer and the other is a double, then it will return a double. And if they're both double, then they'll obviously both return double. Okay. And the last one is round. So round is pretty self-explanatory. The one thing to note is that the return type here, I have no idea why. This is getting super weird. Is long, which is like, so long is literally just a larger integer. And I think it can still store whole numbers or negative numbers. I think it's literally, it just is larger because it takes up more memory. Yeah, so it's 64-bit versus 32-bit. You don't really need to know. No, we do need to know bytes, but this will be in a later video. But we'll learn like long because it's 64-bit. It can store huge numbers compared to a measly 2 million or something by integer. So, but that's not really important because I think as long as you do like math.round and then you do 4.9, as long as the long number is, no, you can't. Oh my God. Okay, you do have to cast it to an integer. Okay, so this will return long. So if you want to store it inside an int variable, you have to cast it, which is quite interesting. If you don't want to, then you can make this variable here long, and then if you print it out, it will print out, it will look like an integer, even though it's technically a long, which is quite interesting. I'm actually really curious why Java doesn't automatically convert it to an integer if it's in the size. Java's kind of stupid like that sometimes. My TA today, or someone also said like the whole 2 integers returning a integer is kind of stupid if you divide them, and it will be like 0. And I think I kind of agree. The more I go on. Okay, double random. So this will return a random value, or pseudo random, whatever. It's basically random between 0 and 1. And I don't know why I got rid of my variables. So you can do math.random and it won't take any number. It's like that. What? Okay, there we go. Eclipse can be kind of weird sometimes. So math.random, and it'll just, every single time you run it, it's going to be a new value. Like that. Like that. Like that. Like that. Okay. Cool. And this shouldn't be a question, but just to note that the values are evenly distributed, not normally distributed. And what that means is that like there's an equal chance it's a 0.1 as a 0.9. And you know what we can do actually is, let me just do this real quick, where long total, or double total, and then int index equals 0. Actually we'll do, no, we can do 0. You don't have to know what the heck I'm doing, but I'm just going to demonstrate it while I talk over it. While index is less than, I really should have just made a for loop. I don't know. I don't know why I didn't. Index plus, you don't know what an index is. You don't know what the hell I'm doing, most likely, and that's okay. Total plus equals math.random. And then we're just going to print out, oops, forgot my parenthesis. We're just going to print out total divided by index. Oh, we don't need this A. Okay, and we're just going to see the average value is going to be, which one? Oh, okay. Okay. And we'll see that the average value is right at 0.5. I don't know if you'd ever need to know that. Also, you can see that I ran through 10,000 examples really. Actually, wait. How many is this? 1, 2, 3, 4, 5. This is a million. And we'll just see it's basically a 0.5. That's actually really satisfying. Can I do like this? Let's make it long. And now I can store really big numbers like this. Oh, too big for long. Okay. Boop. Okay. And that's just gonna run for a while. Actually, you know what I'm gonna do? So we're gonna see how many values. Oh, this is gonna slow it down a lot. That's okay. It's not really okay, but whatever. Oh, it's overflowing. Okay, this is getting stupid. I'm sorry. Actually, I have no idea why it's overflowing. Oh wait, no, I'm running multiple programs at once. Okay, here we go. So yeah, I don't know why I thought it was overflowing. That doesn't make sense. So I'm getting distracted at the pretty numbers. Is there anything I'm so sorry. I'm like wasting all our time. I'm looking at the topic list right now. Oh yeah, we were gonna go over the documentation. So while that runs in the background, we're gonna search up Java math class because I feel like there's more important ones that aren't on the sheet that I have seen in the past. I swear. Oh yeah, these are I was also used. Than any other TPI. What the hell? Okay. So there are these things called constants, and you can kind of think of it as a variable. I kind of want to let this run, so I'm not going to interrupt it. But basically, so you know how we use variables by like a? Well, you can do math.pi in capital letters, and this is equal to like 3.14159 61 62 something like that, with a few more decimals. So you can literally do this. So you can think of it as a variable. Same with math.e. I don't think they're gonna ask about this because this would be I mean that would be a good question for state, but it's not really with computer science or whatever. But 7.21, 82, 81, 82, 84, something like it. It's not exactly this, but it's kind of close. And these are just variables. And I have seen that. I don't know why they're not on the sheet, unless I missed them. No, I didn't. Okay. So we've got some absolute values. We see that there's more than 2, and that's just because like they take on longs and floats and stuff. And this is called, when you have like, I already said this, when you have multiple of the same one, it's called overloading. Where like you have the same purpose with different parameters. This is called arc. Huh. I don't even know what that is. Arc cosine. Inverse. I thought they were talking about like arcs on a sphere or something. At exact. Don't worry about this. Don't worry about arc signs. Seal, copy sign. You can see there's a lot more than what we use, but most of these, like, I don't know why they exist. Floor modulus. I don't know how that works. Literally what? Get exponent. Don't worry about these. This is basically how floats and doubles work. Log, maybe. So you can search up, if you don't know how logarithms work, you can search it up, but basically like it's saying 10 to what power equals the number. Oh, no. 10 e to what power equals the number. So if you did e cubed, then log, and in this case it's natural log technically, but we just call it log for some reason. Log of e cubed would be 3, because e to the third is equal to e cubed. It's kind of weird. And then there's log 10, which is like 10 raised to what number equals whatever you put inside the parenthesis. So if you put log of 1,000, log 10 of 1,000 would be 3. Log base 2 of 1,000 would be 10. Max, mins, max down. Oh, never mind. Oh wait, actually this one's really cool. I think this is, I don't know what that is. Signum? I don't know what signum is. Oh, this may be the sigmoid function. Yeah, oh yeah, it is. Okay. Don't worry about that. Square root tan. Maybe they do degrees? I don't know. Like, if you take pre-calc, you'll know that, like, pi halves is equal to 90 degrees. So if you put pi divided by 2, or math.pi divided by 2, it would print out 90. And this is going forever, so I'm just going to stop it. Look at how close this is, though. Wow. Okay. But, like, if I do this out, and then I do math, or math.2 degrees, math.pi, and then divide that by 2. Oh, fudge. Actually, it's pi halves. Pi divided by 2. This should print out 90. And it does. And it prints out a double. I don't know. They probably aren't expecting you to know this stuff. Maybe later on like, state. But, yeah. And if you are just curious, let's see what pi is. I'm going to take a guess. It's 3.1415962, I think. 3.1415996. Oh, 926, not 62. My bad. I used to know E to like 20 decimals. It's like 2.7182818284, or 824 maybe. 7.182818284590405. Okay. I don't know what an ULP is. Hold on. There's a lot of funky stuff. In ULP, unit of the last place of a double is the positive distance between the floating point value and the double value next larger and max. Okay, then. Good to know. But yeah, okay, so they covered most, but there's a few more they can put. Oh, I have to stop it through here because my alt key's dumb.